So, ladies and gentlemen, let us now save this as nothing less than DES2. Now, that's a bit of a poor name, but we'll leave it for that, okay? It's a bit, transparency is not one of the many virtues that recommend it. Okay. Okay. Great. Okay. Ladies and gentlemen, let us now proceed in the way scheduled, and it's the way articulated. So I'd like you to choose new. The type of the agent is doctor. I would like to, let's go give doctor a representation. And in fact, I know just the representation to give the doctor. And no, I know some of you might think it's a fighter jet or a forklift truck, but no, let's give the doctor the nurse representation, what they call a nurse representation. Okay? Okay, great. So we made the doctor appropriately representing the high preponderance of doctors who are female. We give it a representation accordingly. Okay, now we will, having done that, we will now add that resource pool, right? So for this, we have to go up here. We need to add resource pool, and this resource pool will be called doctors. Doctors. Boom. Okay. Ladies and gentlemen, we are going to have a capacity, for simplicity, for right now, and because of the finicky max, I hereby declare that for the moment we're going to leave just capacity 1 doctors, okay? We might put in place a schedule depending on when the food is delivered. Okay, 1 doctor on staff. Okay, now, let us now divide up this time, okay? So we're going to assign a work, and we're going to divide this up more finely. So I'm going to copy these things and drag them over. I sort of grab them by sort of selecting them and drag them over. And I'm going to rename an workup, initial workup. And that's going to involve the nurse. The nurse is going to be involved in the initial workup. She's going to come in and do height and weight measurements. He's going to come in and do height and weight measurements and do some basic discussion of symptomology, etc. And now, following the initial workup, we're going to assign a doctor. How am I going to assign a doctor? Can you tell me? Sorry? Yeah, we need a C's. We need a C's here. And this is going to be assign doctor, all right? If we only have 1, it'll be easy, but we're going to assign a doctor. And then we're going to have a delay as the doctor does the HPD, the history, physical, and diagnosis, okay? So this is going to be sort of things that require the doctor to be present. And then, ladies and gentlemen, we're going to free up the doctor. How do we free up the doctor? Sorry? Release the doctor. So we're going to have release doctor, and then there's going to be some further workup. So some sort of post-exam examination. And now we're going to add a bit of a twist to it. Okay, so for the post-exam, we're going to have 2 different lengths of post-exam depending on what's required for that patient. Okay, so ladies and gentlemen, If this is a patient that requires more care, more examination, maybe there's some post-examination work from the nurse, which is more intensive. Otherwise, if it's a simple patient, it will be more modest. So I'd like to add in here a select output between the doctor and release doctor and this exam. And the select output will be determine patient complexity. Or it's not actually determine. Yeah. Well, we'll leave it like that. And so one of the ways it will be a more intensive post exam. And the other way, it will be a direct release. No work is needed further from this patient for the nurse. Okay, so maybe we'll actually say for determined patient complexity, maybe we'll call that is patient complex. Is patient is patient requiring post-exam? How's that? That's a little bit. I apologize. I have to do this on the fly. Okay. Is patient requiring post-exam, and to be consistent, I should make it a capital E. Yeah. And with probability point 3, they're going to require the post-exam. Now, when we come to hybrid models, this won't be a probability. This will actually be examined. This will be based on the patient's underlying status, the agent's underlying maladies, the ills that have befallen them. But right now, it's just we're flipping a coin. With 30% of patients require post-exam. Okay, now let's fill in these things. Assign a doctor. So who needs more time to just put those in place? Okay, a little bit more time? Be happy to provide it.
Does it go to the exit or release nurse? That bottom
one? Go to here.
Okay.
Could you just maximize that pane and then zoom in on the pieces? I think that would help.
Sure. So they don't. Soon we're going to need to see the properties, but
if everybody's just assembling it, they'll get to
yeah,
understand what's going on.
yeah. So I'm just using my mouse button to zoom in, and so there's assigned doctor. There's a history, physical, and diagnosis undertaken. Release the doctor. And then we check, do they require a post-exam? If so, they require this post-exam. Otherwise, they go on directly to release, to be released through the nurse.
How does the release doctor know that his doctors you're releasing and not everyone?
We're going to get to that. We indicated explicitly. Now, maybe it's worth noting the conceptual model of this is that each of these blocks characterizes the workflow, but we characterize them in a way that we consider kind of a particular patient. How do we deal with them? How do we deal with them? Their characteristics. They may be assigned to a doctor, and we can use that doctor that's assigned to them. Maybe they're assigned a nurse. We can use the characteristics of that nurse. In short, we're sort of these blocks, the logic of them is undertaken with respect to the entity that's flowing through. So the entity has some characteristics like resources assigned and will release their resources. Okay?
At the moment, basically that nurse is with the patient all the way through. They're not released after the first workup.
Correct. They're there while the doctor takes the history, physical, and diagnosis and does the diagnosis, and the doctor will then tell the nurse, she'll say to the nurse, could you then do some further measurements, maybe do an ECG measurement on this patient, or could you take their blood pressure? Could you hold them afterwards for an oral glucose tolerance test, or what have you? And the nurse, he'll then act on those requests during the intensive post-exam if it's required. But 70% of patients just go on directly to not require further nurse or doctor attention following that, following the HPD. Okay? Are we okay? Anyone like a little bit more time? Okay, we ready to go on? Okay, so let's fill in these things then. It shan't take long. Okay, so we didn't change anything with the initial, the initial workup, we need to, that's just the one we've had in place, right? We didn't change that, we just changed its name. That's the one as we had it before. Anyone need the parameters of that? This is just what we had earlier. 0.5, 1, and 1.5 hours. Assign doctor, okay, we have to be careful because that's a long time for an initial workup. Let's change it to, let's just decrease it by a factor of 10. Okay, so it'll be 0.05, 0.1, and then 0.15 hours. Okay, so it takes on average 6 minutes. It can take 3, and it can take 9. Okay? Okay, so let me put that up on the big screen. This is all I did. I just divided these ones by 10. Are we okay? Okay, next, ladies and gentlemen, assign doctor. How are we going to say where the doctor comes from? How do we specify that? You've seen it before once. Where do we say it? Resource sets. We do a plus and we choose doctors. Okay? Okay, great. Now, having done that, now there's the history, physical, and diagnosis. And we'll leave that in the same way. We'll leave that there. The nurse is there through that, we'll assume, to help out with various tasks, etc.
We'd also divide by 10, would you, times?
I was thinking, for taking a patient's history, we could do it by 2. Okay, you want to do it by 2? That's good. So it takes between 15 minutes. It can take, on average, half an hour, and it can take as long as 45 minutes. Oh my gosh, this says seconds. We should do hours. That's scary. That's scary. I know in Australia they can be efficient, but yeah. Okay, now, there was the question earlier from Chris. For release doctor, how do we know to release the doctor versus the nurse? Now, we have to be very careful here. For release doctor, do we release all seized resources? No. We'll specify from a list of pools. Okay? Notice we could say all resources seized in a given seized block. We could do that away. We'll just say list of resources for particular pools. And what pool should we specify? Doctors. Indeed. And then, ladies and gentlemen, for the post-examination. So I would recall that for this thing, is patient requiring, well, it should be does patient require post-exam, but that's fine. Probability is 0.3 that they'll require a post-exam. The post-exam here is only going to take, oh gosh, instead of, I missed the boat with it. I should specify these in minutes because they're so short. It's going to require no fewer than 10 minutes, no more than, or it can require on average 20 minutes and no more than 30 minutes. Okay, something along those lines. Maybe no less than 5. think about blood pressure, cough, and so on. Okay, no less than 5, 20 on average, and up to 30. Okay? And then, ladies and gentlemen, we will release the nurse. For release the nurse, oh, sorry, I really should have waited more. I'm sorry. Apologies. I changed this to minutes, and I made it this. And really, to be consistent with my injunctions to you, well, I should really do this. Just, you'll spare yourself some grief if you're consistent with that. Okay? Are we okay with this? Who requires a little bit more time? Okay. And now, ladies and gentlemen, release nurse. I could say all seized resources because there shouldn't be any left except nurses, but I'll again say seized resources from the nurse pool. And then we're done. Let me put this up here. Who would like me to show one of these blocks? Who would like me to show one of these blocks to you? Would you like me to do a tour through the blocks again? No? Okay. You've been blocked out. Okay? Are you ready to run it? You ready to run it? Okay, let's go run it. Now, 2 types of interacting resources. The doctors are only used for part of the equation. The nurses are used in more of the equation. There's only one doctor. Which resource do you think will be used more heavily, doctors or nurses? Okay. 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 So doctors and nurses are almost neck and neck right now. But there's only one nurse on. Okay, now doctors are here 84, 82%. Okay, now there's 4 nurses, okay? Still that doc. Okay, here we are. Capacity utilization is pretty good and pretty high for nurses. You notice quite a few people are still bulking, right? Okay, let's try. I think lunch is still on its way, right, Jeff? Yeah. Okay, so no worries, Dylan. We're going to now deal with the next request. So we have doctors' utilization being somewhat less than nurses. If we were to want to increase one of them, which would we increase? If we want to most decrease this, let's create a graph. Let's create a graph here that will show sort of the utilization associated with this. What do you think? So let's create a graph, and let's do 2 time plots in clinic. In each clinic, we're going to have the time plot. Okay? So here we go. Within this clinic, we're going to go add a time plot. And whence does the time plot come? And from analysis, we're going to add in the time plot. And for the time plot, we want to use it to plot out the resource utilization. Okay? Great. So we're going to say plot resource utilization. Are we okay with that? Are we okay? Okay. Ladies and gentlemen, for data, I would like to add in a data item here. This is going to be nurse utilization. And its value is going to be nurses.utilization. Nurses.utilization for nurse utilization.
And you're
Next.
doing this or anything like that there.
Oh, really? I should have this dot nurses. Thank you. To be consistent. This dot nurses utilization.
And utilization is a command within any logic with this?
Yeah. So every resource pool knows how to do certain things. So let's go see what it knows how to give its. Oh, okay, speed is not so relevant. Its capacity is one thing. But more to the point, it has all these things you can request of it. For example, is it which number are busy? And you can ask for here, as part of this, one of the things you can ask it to do is to tell you its utilization. Okay. This is one of the things here. And it says returns utilization of the pool. It automatically knows how to do that. Okay? So I said for utilization, and let's do the same for doctor's utilization. Doctor utilization. Okay? And the value here will be this dot doctors dot utilization. Are we okay with that? Okay? Ladies and gentlemen. Man, I should really be doing this. They've got the right idea back there. I should really be doing this on the podium. Then I could stand. Okay, great. So that's what we're going to do. And then we're going to go down and, as normal, we're going to just say display up to 1,000 samples. Just because it's a little bit small. Okay? After all, it's and then it says time window is 100 model time units. That's awfully little. Awfully little. Maybe we'll change it to 168 time units. After all, time units are in hours, so 168 hours is a full week. No? 168. Okay? We okay with that? So we're going to display, by the way, this is maybe a little bit opaque. So maybe we should say 1 week. What do you think of that? Yeah, I know. In Dylan's generation, they would call it sweet. You could just say what unit to use for that, okay? 1 week. No 168, where did that come from? Okay, can we run it? What do you think? Who needs me to show something? Okay, oh, where is it? Where is it? Wait a minute, I put it in main. Oh, huh? Okay, oh, of course. Yeah, it's displaying at the top level too. Okay, what do you think's going on here? Characterize for me a hypothesis for what we see. You notice that doctor utilization has gone down. Nurse utilization remains very high here. Doctor utilization has gone up and then gone down. Anyone? So we have nurses at sometimes it's 1, and then based on the time of day, it'll go to 4 and so on. Okay? Okay, so you'll notice there's some fluctuation associated with doctors here. There was some fluctuation. Now it's more or less, okay, that's interesting. It's almost constant.
Any logic probably just takes a long review average of it. It probably just smooths it out.
Yeah, that's probably true. It's probably just smoothing it out over the long time. That's too bad. There's probably a way we could tell it restart the calculation, but that's fine. Okay, ladies and gentlemen. So suppose now we were to add, based on what we saw in that graph, would you think adding doctors or adding nurses would be most helpful? Nurses, because doctors have a lower utilization. Suppose we were to add an extra nurse in. When to add them? And unfortunately, it is smoothing it out. You'll notice these cycles. that are occurring at first. Why do you think there are cycles there in doctor utilization? Well, there's certain times a day where doctors are more the limiting resource, right? Certain times a day when there's lots of nurses around, but few doctors. And doctors become more highly utilized then, right? You get multiple nurses handling patients each at the same time, and the doctor needs to come in and do things for each of them. But at other times, it's nurses that are the limiting resource. And you only have one nurse, and the doctor's idle a bunch of the time. The doctor goes off to his doctor's lounge, or her lounge, and she's waiting while the nurse, he's still examining the patient, right? So this utilization fluctuation reflect partly the sort of scheduling that we put in place for nurses. So what do you think? Based on that, okay, add nurses. Nurses are kind of maxed out for utilization. But where should we add them? During what times? Night? Mornings? When should we add them? Nighttime. Okay. So here are the nurses. Should we bump it up for the evenings from 1 to 2? What do you think? Okay, let's bump it up from 1 to 2. Okay? Now we really should have, what I really would like to have done is to create a graph of the timeouts, the bulking, the fraction that actually go bulk. And so now we're running it, and look what happens. What are we seeing now? Okay, now both are pretty well utilized. What does that tell you? What does that tell you? First of all, you might have thought we're adding enough nurses that nurses wouldn't be used all the time. No, they're busy. They're busy. But doctors are now more busy, right? I mean, are equally busy. They're more busy than they used to be. They're now equally busy to nurses here. We're in a situation where doctor utilization is pretty consistent too. Now there is a question over what time period this is smoothing at. I agree with that. But we have doctors and nurses both being used at high capacity. Let's go look at the bulking. The bulking here, 2,800 people have bulked, about 800 have been served. So ladies and gentlemen, suppose we wanted to now to really decrease it. So we have very little people leaving without being seen. How would we do that? Should we try upping the doctors and nurses counts? How far do you think we'd have to up them? They're coming in 10 per hour on average. How far do you think we'd have to up them? Well, we'd have to up them by an amount that the time it takes to deal with the average patient is certainly no more than a certain number of minutes per patient. Depending how many nurses we have, we could have multiple things going on at the same time. We certainly we want to be able to keep up with the patients, right? We want to be able to process through the nurses and doctors 10 patients an hour, okay? Okay, so what do you think? Should we increase the number of nurses? What should we to what should we increase it? Should we double it again? You think that will be enough? So we'll double it across all hours? Yeah? What do you think will happen there? Should we try that? Doubling it across all hours? 4, 8, 4, 4 for the schedule? Okay, let's suppose we did that by itself. Shawen's one step ahead. Suppose we were to do that by itself. Okay, now what do you think is going to happen? Well, nurse utilization is still pretty high, but doctor utilization is even higher, right? Okay. Suppose we were to up the nurse schedule even yet further, another doubling yet. So we have 8, 16, 8, and 8. Oop, that's 18, 16. 8 and 8. There we go. There we go. Ready? Let's try running it with that. Suppose we have more nurses. Do you think they'll be fully utilized? Here's nurse utilization. Are they going to be fully utilized? Pretty close to it. Okay. Okay. Let's try doubling it yet again. 16, 32, 16, and 16. Okay? 16 nurses on staff. 32 in the day. 16 during other times. What do you think will happen now? Okay. Okay, let's go down and look at the clinic, see what's going on. Are there people balking? Yeah, there are still people balking. Nurses' utilization and doctors' utilization remains very, very high. Very high indeed. We have more people balking than we do being seen as of yet. Why is that? Why is that? Anyone?
They're not patients.
That's right.
Impatient patients.
They're impatient patients. How soon are they leaving by? Well, they're leaving by between 0.5 hours after 4 hours, and we're keeping actually quite a few waiting there. Quite a few waiting. Okay? Okay, let's try this. Try this again. So we have quite a few in the queue, but most are indeed leaving. Are indeed leaving. Okay, now we could keep on doubling this nurse's schedule. We could keep on 32 at 64 nurses. Do you think this is going to help? Let's try that. Okay, here we go. Utilization is still at something like 99%. What's going on here? What's going on?
Can I just ask a question about something?
Sure.
Did we ever change how many people could be going through initial workup at the same time?
So that's a very good question. So let's go back and look at it. Capacity is 1. Capacity is 1 for this. Okay? So there's still a bottleneck here in terms of examination. If we set it to be maximum capacity, let's try that. Now what are we going to see? We'll see a rise here initially in terms of the level of utilization. And we'll still see quite high utilization. We have better sort of allocation, but it's still quite high. Ladies and gentlemen, let's now change how many doctors there are. Okay, so instead of 1 doctor, let's make it 4 doctors. Okay, 4 doctors in turn. I'm conscious of the fact that food has just been brought in. Okay, so we're going to make it 4 doctors here. Okay, we have heavy utilization that remains, not quite full, and we still have a lot more people going here through the system. Following Dylan's question there, let's go down and check this, and let's consistently go and set these to maximum capacity all along here, so that it's not just those don't become the bottleneck. And let's try it now. Okay, so now we're seeing slower sort of maxing out of the system, but it still rises to quite high capacity utilizations. It remains incomplete as of yet in terms of nurse utilization. We see doctors and nurses each sort of occurring during this time. And here we have a curiously small number in terms of 4 undergoing the HPD. Why do you think that is? Why is this only 4? There's only 4 doctors on staff. So we're going to further change the doctor pool here. Doctor pool from being 4 to being, let's say, 10. Changing that bottleneck. Okay, here we go. And now we're seeing a very different situation. We kept on adding nurses, but those nurses were actually being kept waiting by the doctors. The doctors were needed for this assignment. By that time, the nurse was already the nurse was reserved. Her capacity utilization or his capacity utilization was very high, in part because the nurse, he was waiting for the doctor, and she wasn't available. And so the nurse was kept waiting during that time. So, ladies and gentlemen, now we have a capacity utilization that's considerably smaller. The doctors were the primary issue for that. The doctors were indeed the bottleneck. And if we go and we experiment a little bit more, here we can go down to the level of a clinic, for example. We'll find that the nurse utilization is very small indeed, but the doctors is about 50%. How many people are balking now? Basically nobody. But do you think if doctor utilization is 50%, do we need all those doctors to keep that throughput? No, we don't. So let's go down to doctors. What do you think we might set the doctor capacity to? Maybe 6, just over 50% of that value. Okay, so let's go try that. Okay, let's go. Okay, now we have utilization, doctors closer to 83%. How many people are balking now? How many people are leaving now without being seen? Essentially no one. Nurse capacity utilization is still very small. We have way too many nurses for what we need. Doctors are getting up there in terms of capacity. Now, if your pure concern was just working doctors continuously, which is of dubious merit, we could change doctor capacity. Let's try 4. What do you think would happen at 4? Do you think we'd have the doctors max out? Okay, at 4, the nurse utilization, the doctor utilization, both go up to very high levels, and once again we have patients balking.
So can you set that to do it automatically for the number of doctors relative to the number of nurses, given the criteria of setting?
Yes.
No balking? Can you get the model to do that?
Yes, you could.
Optimize it?
Yeah. You could optimize it. You could do an automated sensitivity analysis where instead of me exploring this manually, it would be actually performing that in an automated way and then present to you the summary of the results. And we'll see likely some of that in the next few days. Okay? Yes?
At the moment, you've obviously said in the doctor resource pool the capacity of whatever, 6 or whatever. That's basically constant at all points of the day. There's no variation at all of that.
There's no variation. We could, by the same token we did with the schedule, we could put in place one for doctors and have it. It's a little bit of a higher, there's more things to tweak, and so I didn't want to aspire to that. Yes.
So basically it varies with time, different points of the day?
That's right. You could, yes, with a bit more mechanism, you could have in place drawing doctors from some sort of distribution. But in any case, making them by hour of the day, be certain limits, you could certainly do. And in fact, if you go down and look at, by the way, almost no balking with 5 doctors, right? So we were barking up the wrong tree, adding nurses, thinking nurse utilization is maxed out. We weren't actually pursuing the right thing. Nurse utilization was maxed out because doctors, they were being kept waiting. They were reserved, they were allocated to patient, they were being kept waiting because of the doctors. So once we started pursuing the doctors, that gave us our key leverage point. Now, let's go and just to address that question from Matthew here. If we go look at the at doctors here, thanks. Yep, it's lunchtime. You can define their capacity by an on-off schedule, by group schedules and shift, or by the schedule. This is what we used, but there's some additional texture that you could get. But fundamentally, you can do that. You can also set it dynamically. So if you wanted to, at some point trigger a greater availability of doctors, maybe a surge type of phenomena where you have a need, you could actually do that dynamically. Add those doctors in. Okay? Okay, so that's it for now. Thank you for your patience with that. We've tried to address two of the things. For the visual one, if there's time and interest later, we may do it. Otherwise, there's a decent video of me doing that online, which I did just before coming here. So happy to do that too. So lunch is served, and we will reconvene in, 45 minutes? Yeah.
No, not that one. The next one. It's the listing. That complexity
How's it going today?
It's going pretty well. Thank you very much.
That's really good.
Yeah.
So we sent the surveys out.
Okay. Great.
So Jeff sort of had the final say on that.
Yeah.
Oh, are you
mic is still on.
Yes, it is. I'm just performing one final experiment here for people online.
Oh, I mean like your lapel mic echoing through.
Oh, I see. Okay, it's okay, fine. I could turn that off. It just picks up better with that on. So, yeah. Give me just a second. Oh, thank you so much. Appreciate that. Pardon me, as I just want to narrate here. So we'll notice that without the maximum capacity being initial, these elements do become a bottleneck, these workup elements. Whereas if we set them to maximum capacity, we could have as many people in there as are required or as are allowed by the resource constraints. And that supports the greater throughput we saw just a little bit ago here, where we have lower utilization. Where we have the system realizing its full capacity with approximately 5 doctors. Okay, so I'm going to stop recording.